Looks like recording has started.
There we go.
Yes.
Okay, hi folks. Welcome to the May C++ Users Group meeting, Northwest C++ Users Group meeting. It's giving people a few more minutes to kind of filter in here. We were just talking about CPPCon this year, and it is starting to get going. So there will be a CPPCon this year. Everything I'm reading says it will be a hybrid format. They are looking for volunteers, so if you're interested in volunteering for CPPCon, please get a hold of Brett Searles, and he can coordinate that on this end. Let's see. Other items, we're continuing to meet remotely for the time being, and I think we're going to continue to do so at least, I'm going to guess, for the next several months. We do have the reactor room signed up at Microsoft when Microsoft opens up their campus. So as things open up, we'll kind of see what we're doing there and, basically play it by ear like we have for the last, year and a quarter, roughly. That's all I've got for general announcements. So turns out I'm the speaker tonight, so I will go ahead and introduce myself. I'm Lloyd. I'm the current president of the Northwest C++ Users Group. And yeah, you guys pretty much know who I am and so forth. I've been programming and professionally for about 30-ish years now, 35 years, something like that. And tonight we're going to be talking about components of successful software projects. I'm going to get a screen share going here. Get the chat window up. So, feel free to raise a hand or, flag me or something if there's a question as we go through. Tonight's talk's going to be fairly light, but it's kind of a best practices talk. So, open discussion is appreciated. Where did my screen share go? There it is. Okay. And of course, it just took my screen share and moved it completely off of any screen I'm looking straight at. That's okay. You guys don't see me, so turn my camera off too. There we go. Okay, now I can look at the other screen. So anyway, tonight's topic is components of successful software projects. And basically, we're going to talk about this in several phases. And the phases are kind of outlined, as you would do a project. The planning and design phase for the project, the construction phase when you actually build the project, the verification and validation phase. And depending on what you're doing, this can vary quite a bit. Anything from just, hey, this works, to a very formal process. I've also included what I call a hardening phase. This is something I do with projects where I have control of the project. The hardening phase is essentially it comes at the end of the project, and it's something I found that's helpful to, you basically try and break the project. So instead of just using it, you do stress testing and, power outages or whatever is relevant for the project, and actually try to break it, make sure it breaks in a graceful fashion, and that you, furthermore, that you really understand where the bounds of the project are, or the bounds of the technology are. So in the planning and design phase, basically, there's a whole bunch of steps you could do. And we'll go through each one of these in order. All of these, they're not necessarily in any particular order in this. Well, there's a little bit of an order. You probably should start with the problem statement. But some of the others, it can kind of be whichever way you want it to go. And let's see, let's just dive in. So the purpose statement. This is something I've found almost no projects actually do. But it turns out to be one of the more important steps of the project. It can be just very simple, a 1 or 2 sentence statement. Why are we doing this project? What is the reason we're going to spend time and money on this project, and what do we hope to get out of it? Furthermore, what problem does this project solve? I've seen many instances where people go start a project and they actually do not have a clear indication of what the problem they're trying to solve is. They complete a project, the project actually works, but it doesn't solve the real world problem. And then, of course, nobody uses it, nobody buys it, and you essentially have a failed project, even though the code works, it passes all the unit tests. Everybody's happy because they even got done on time, but it doesn't solve a real problem. The other thing having a purpose statement does is it focuses the project. So it also keeps you from getting into the feature creep paradigm, where the project starts out doing one thing and ends up doing something else. There's very little to no cost to actually create this project or this purpose statement. Oftentimes it will happen naturally. You've got a problem to solve, and you're good to go. I'm going to say this step should never be skipped. So one of the other things we'll talk about with each one of these tonight is when should you absolutely do this? When is it optional, and when can you skip it? And what are some of the implications if you do skip it? So after you get a purpose statement, the next thing to look at is requirements. This is a formal or semi-formal list of what the system must do. If you're some of you know I've been working in aerospace. They have usually a very formal requirements process. DO 178B and C and some of the very formal specifications for how you do a project, specifically list you have a requirements section. And this is how your requirements should be written, and there's high level and low level requirements and so forth. You don't necessarily need to go that far, but expanding on the purpose statement and really laying out, this is what I want it to do. It's going to run on this operating system. We're going to build it in this language. It's going to be able to process 4,000 transactions per second. Whatever is important to that project, getting it written down and being able to keep your focus on it during the project is another way to prevent feature creep and guide the project. These also typically translate into your top level feature tasks. So for instance, if you're using Jira or some other project management tool, your requirements will basically become your first level tickets. Now you'll want to break them down further typically, especially for a large project, but you're already building out this task list off of your requirements, and this will just flow on through. It also defines when the project is done. I don't know how many people have worked on a project that kind of just keeps going on forever, and there's always a new feature, and it never quite gets done. When you've got your list of requirements completed, then you can say the project is done. This is also justification for the people who are assigning the budgets and the resources for the project to say, here's when we're going to be done. Here's what we have left to do. If you have requirements that flowed through to your ticket and task tracking system, you're much better equipped to answer the budgetary and the scheduling questions. Very simple projects, you might be able to skip this. The other place you might be able to skip this is on research and development projects. Sometimes you're going into an area and you really don't know what you're planning to do. It's an exploration. So part of the process is the journey of going through, and that's fine to skip in that case too. Next one's process design, and this can be done pretty much in parallel with the other two, and I usually do this when a team is being formed. So this is the development process we're going to use for the team. So not necessarily for this project, although it could be. It's for the team overall. What are we going to do for version control? What's our check-in and code review process? What are our testing process? This presentation can actually be used as a starter checklist for developing this. We're going to hit, as we go through the presentation, we're going to hit all these major, these are things to think about elements. And this will actually form a pretty good checklist for figuring out how you want to do this. It also forces the question of what is appropriate for this particular project. Usually when you're working with a team, the team is going to get assigned projects that are fairly similar in nature, and that's going to be centered around the business that you're in. If it's a research and development team, most of the projects are going to be R&D focused. If you are building web apps, well, we don't tend to do a lot of web apps in C++, but if you're building applications, most of them are going to be applications of a particular nature and a particular problem domain. You may not need to do this if there's an established process already, but you should lay out, this is how we're going to function as a team. This is how we're going to handle tickets. This is how we're going to work, manage our workflow. If you're going to use a particular process, say Agile, what exactly does that Agile process look like for us? Are we having a 2-week sprint? Are we having a 1-week sprint? I've worked with a group that did 2-week sprints during development and then 1-week sprints at the end of the project to pick up the pace a little bit. You want to answer all those questions at least starting before you really get into the project. Okay, next one is system design. So this is going to be a more detailed design of the system itself. So where the process is, this is how are we going to build this? This is what are we going to build? I typically like to use some type of modeling or a diagramming language for this. UML is my favorite. There's a bunch of others out there. But you want to diagram out what the different components of the system are. You can, if you only get to diagram, some groups are very light on this. They don't like doing a lot of diagrams for some reason. But if you only get to diagram a few things and plan out a few things, the key point is to get your interfaces designed. Where any two components touch, get that interface documented. And then when you break the system apart and you have multiple people working on it, at least those people know where their touch points are and how to talk with each other. Again, this can be very simple to very extensive. I would say this should never be skipped. A simple diagram on the back of a napkin is better than nothing at all. You will find just the act of doing these diagrams and going through the process of putting it on paper, you'll frequently find architectural errors, things you didn't think about, things that can be improved, and you've caught these things before you've actually started coding. I also use the system design to help pick libraries. So as I'm decomposing the project into its components, you're able to look at the project and say, okay, I need a component, I need something to do this, I need something to do, task A, I need something to do task B, I need something to do task C. And now you can make a build or buy decision on each one of those components. Task A, this is our bread and butter. This is something that doesn't exist. This is what we're developing. Task B, hey, there's a standard library over here, or this set of libraries. We can save some time if we just pull that in. But you'll be able to much more easily pick up the components and figure out what do you want to build, what do you want to buy, what do you want to pick up off of open source, so forth. The interface design, this defines all the interfaces in the system. The cost to do this is generally pretty minimal. If there's a protocol involved, you'll define the protocol. If there's hardware involved, like a microcontroller, I typically do a port mapping. So what signals are coming in and out of which pins. Basically, if you don't do this, your project is going to lag because as the different people are trying to talk to each other and work these things out, they're going to make different assumptions. They're going to go back and forth. If you only get to do one design document, the interface design is the one to do. If you've only got one developer on the program, you might be able to skip this. I found that even when I am the only developer, just getting this stuff down gives me reference material to build from more quickly. The security and threat modeling, we could do a whole talk on this. Actually, you could do a whole series of talks on this. It's not necessary for every project. Not every project has a high security level around it or security aspects that you need to consider. Some do, and some are if you're working on a financial application, for instance, or a medical application. There are very strict requirements that you have to meet for security and how you handle information. Should also be thinking about specific industry requirements around this, specifically personally identifiable information, names, social security numbers, phone numbers, addresses. These all need to be handled in a secure fashion. One that I came across, I didn't realize was there actually until we got into the project, was the Children's Internet Protection Act. If your project involves children, there's a whole nother set of requirements around how you protect that child. And it's a whole venture onto itself. International Traffic and Arms Regulations, ITAR, that governs aerospace and rocketry, for instance. These are just a few of them I've seen. There's tons of them out there. If you come under an area where there are specific requirements that you need to meet, you absolutely need to get these things in place up front. If you do not, there will be documentation and design requirements that you're just going to have to come back and retrofit later, and that's extremely painful. These types of things need to be thought through and designed in right from the beginning of the project before you even write a single line of code. Okay, next is the construction phase. So we're actually going to build the project now. We've designed the project. We know why we're building the project. We know how we're going to build the project. We've probably got the team, reasonably put together. We know what people we need to hire. We don't, that type of stuff. Now we're actually going to sit down and start doing it. There's been a lot. This is going to be probably one of the shorter sections on the talk because there's been this is the part everybody does. Everybody builds the project. It's a question of how well. So code comments. Self-documenting code is necessary but not sufficient. If you don't put comments in your code, it's only going to capture what the code does and not the developer's intent. And again, different groups have different styles of this. Actually, something I should have mentioned in the planning section is the coding guidelines. You should adopt a coding guideline for your project. If nothing else, just a personal style that you maintain. At a minimum, I'm going to say each module and class should have a description. Each function and method should have a description. Every magic number should be documented. And any complex algorithm should be documented. And complex depends on your problem domain. If you're in a research field and you're just simply implementing an algorithm from paper, well, then just reference the paper. If you're creating your own algorithm for something and it's involved, probably want to document it. I'm not going to go too deep onto this. Static analysis. I've already covered some of this in my Culture of Code Reviews talk, which is listed there. Basically, the goal is to let the developer stay focused at the high-level concepts and let automation catch the detailed mistakes. It's fairly simple to set these up today for basic checks. This I'll also note this tends to play into your style guide, your coding guidelines. Basically, pick a style guideline or coding guideline that matches some standard that's supported by tooling. If you do that, then it all just kind of plays nicely and you don't spend a lot of time customizing your static analysis tools and your various linters and checkers to your own standard. There's free, easy tools. Yeah, we've talked about that quite a bit. Code reviews. Are you going to do code reviews? How are you going to do code reviews? I'm just including this one here for completeness. If you want a little more in-depth on that, please see my talk on culture of code reviews. It was about 9 months ago. Okay, unit tests. We all know what this is, or we better know what this is. Again, I'm including it here for completeness. I'm not going to go into too much detail. I will note that when you have unit tests in place, various other development tools, such as CI or continuous integration, become much, much more useful. So one of the other things that we're going to see with these, as we go through this list, all of these elements are helpful in their own right. When you begin putting them all together, it becomes a scenario where the sum is greater than the individual parts. They work together to form a system that is more reliable, flows smoother, has less surprises. It's very common for me to see groups implement some things, but not all of them. When you put them all together, basically things just gel a lot tighter. You may want to skip unit tests in the case of experimental or prototype projects, especially if you use a test-driven design methodology. That methodology kind of dictates that you know what you want to build before you actually build it. And generally that's the case. Sometimes when you're doing experimental or prototyping work, you do not know exactly what it is you want to build or need to build. And in those particular cases, the unit tests actually, I find, do slow you down. It's not to say you won't come back later and add them, but trying to do them as you write the code or with a test-driven design methodology, that doesn't work as well in those scenarios. Excuse me. Continuous integration. So this is an automation of the development and deployment process, and typically the testing process as well. If people haven't used this, there's tools out there that do all this for you. You don't necessarily need to deploy those tools. If you're in a big, well, not even a big, but a moderately sized group that has multiple developers, it's usually worth getting continuous integration in place because it lets the team work together more smoothly. It also automates your development process. So when we talked about the development process and designing that, you would typically embody that in a CI system. So you're not doing all these things manually. It's helping you through the process and guiding the team along. These can be rather expensive to set up and maintain. Oftentimes, you'll have a dedicated member of the team who's responsible for the CI system and dedicated hardware. One thing you can do, if you're on a small project, and I'll do this if I'm just a single developer on the project, is basically just put it on my desktop. I don't do a CI, but I'll put a block in my make file, or I'll create a script that runs all of my static analysis, runs my unit test, runs my style checker. I'll typically call it something like make check. And then just before I commit, every time I do a commit to the repository, I'll run that check and make sure that every time I'm committing, I'm clean. If you're a disciplined person and you tend to do these things pretty automatically, that works. If you're working with a team, people are going to forget. So you want a CI process that does this the other way around. You commit, and then the CI process picks it up and does all your checks for you. Merge checks, speaking of exactly that. These are basically automated checks that must pass before any commit can get merged. So you can do your commit, but you cannot merge it into the main line until you've met essentially a set of quality gates. Typical checks to include code review, all issues resolved. So if you're using GitLab or GitHub where there's online code reviews, there's a checkbox you can say that you cannot hit the merge button until all of these discussions are marked resolved. Do the unit test pass? Pretty straightforward. Does the style check pass? Does the static analysis pass? This is actually very, very simple to implement and set up if you've got everything else in place. So if you're already doing a CI process, these are all just checkboxes that you set up. If you've got the unit tests in place, you just run it, say, make sure this value or this process passes. The goal of this is to ensure the protected branch, or typically the main line, is always in a good condition. In other words, it builds and it passes your basic tests. Doesn't mean it's bug-free, but it means you can actually build the project, and should anything come in that stops the project from building, you know about it immediately and you've protected everybody else from that break. If you do not do a merge check, what you'll typically see on the team, and it's not deliberate, it's just because things happen, somebody will check in a bad piece of code and that'll break the build for everybody, and the entire team halts until that build break is taken care of, or they have to do workarounds or various other things. This dramatically improves the velocity of the team. Small teams, you can skip this on small teams and use like a make check. But if you get any bigger than, I've got 1 to 3 in the slide. I'm going to say if you get 3 or bigger, really, you should start getting these processes in place. If one person stops because he's got a build break, well, he's got to go fix his own build break anyway, so that's fine. 2 people, okay, you can work together, get it fixed pretty quickly. The minute you get the 3rd, 4th, 5th person in there, instead of one person stopped, you've stopped, most of everybody. So the cost of not having this really starts to add up. Okay, next one's the verification and validation phase. This depends a lot on what type of project you're doing. Basically, what you want to do in this portion is go back and say, does the system meet the requirements? If you do not have requirements, you don't know if you've met them. So this goes all the way back to the beginning. To know if you've actually built the system you intended to build, you have to document it. We'll talk about integration testing. If you have a formal customer, customer then gets to test it. This oftentimes has a contractual obligation where you're going to hand off the project to the final customer, and that customer then gets to say this, this is acceptable or it's not. Again, if you have requirements, you have a concrete set of checks to go with. I've been on projects where there were not concrete requirements. There was a customer, and the customer expectations and the project, didn't necessarily line up in certain cases. And then finally, there's as-built documentation. I actually can't see the hand raising. Does anybody have a question? I'm hearing maybe a little bit of question in the background. Okay, I'll keep going. Okay. So requirements testing. Typically, there's one test for each requirement. The system shall process 4,000 transactions per second. Well, set up a test and see if it processes 4,000 transactions per second. Pretty straightforward. You're basically going through each one of these and demonstrating that the system meets the original goals and intents. These can be time-consuming to build, but they're essential. And they're typically a combination of unit tests and integration tests when you actually build this out. If you do not have this, you cannot demonstrate a successful project. You may have a completed project, but you do not know whether you've actually met the goals you started out to meet. And in the case of if you've got a customer, you do not actually know if you've solved the customer's problem. Integration testing, this gets intermixed with the requirements test. Essentially in integration testing, what you want to do is test with any other component that your system is supposed to interoperate with. That could be hardware, that could be a web server, it could be a data source, it could be any other component that's not yours, you want to pull into your integration test and do some form of live testing against it. This typically also includes error conditions and edge cases. So what happens if a component goes down in the middle of a transaction? Do you recover gracefully? What happens if your hardware is not present, or some piece of hardware is not present when you start up? Do you flag it and notify the operator, or do you have to go on, and debug it? Can you skip it? How many people have heard of Knight Capital Group? So I'm gonna call this one out because it was a very high-profile failure of a financial organization because they did not properly do integration testing with their trading house. Essentially, this was they were doing automated stock trading. They had a bug in their code where essentially the orders were not being executed and acknowledged as expected. The bug snowballed. The system continued reissuing orders that were actually in play already. And I believe that they went through $500 million in 30 minutes before somebody finally realized what was happening and got it stopped. Something like that, costs can get pretty high pretty fast. And it did take the group down. So always do integration testing. In the case of hardware and machinery, you can damage hardware, bits flipped, gates or valves that should be opened, valves that should be closed when they really get flagged open. All of these things can really be problematic. Customer testing. So this is when you hand it off to your customer. It's also typically called beta testing or acceptance testing in many cases. This is where the customer is going to come in and use the product for the first time and say, does this meet our needs? Now, again, if they've got a requirements checklist to go down, it's going to go much smoother because they're going to go down the requirements checklist and not make up new things as they go along. See, it's always going to be present even if it's not official. So even when I'm building a project for myself, I'm the developer, I'm the end user, I'm never going to leave my office. You always get to a phase where you've completed building the project and now you're going to try and use it. And if you miss something, you're going to spot it. It's best to have an official process and actually manage the feedback. So if you're working with a customer, or even if your customer could be internal or external, it's always best to have this handoff process where it's like, we believe we're done with this. Now it's yours. Check it for these things. And this can actually be at the end of the process, or it can be continual throughout the project in the case of milestones. So even though I've got this listed kind of at the end, you can do it as you go along. I don't mean to imply this only happens at the end of the project. That's not true. But you should have defined points where you're going to hand off a fixed set of features to the customer, and they're going to give you feedback on it. And there should be a way for them to give you feedback. That feedback then goes through the team, back to the developer, and you close that loop. Finally, as-built documentation. This is a step that I typically do not see teams do hardly ever. Even in teams that are very good about documenting up front, they do not typically come back and validate those documents to make sure this is what we actually built. And again, this is a two-way process. Do the documents reflect what you built? And does what you built reflect the documentation? So you want, just like you're handing off and syncing with the customer, you want to basically sync the project with your documentation. In the case that you've got a customer, you're typically going to formally, deliver the documentation to the customer as well, and they're going to want to review that and so forth. One benefit I find when you do this, when you have a documentation system, and I usually try to do a live, all my documents are live during project development. When you bring a new team member onto the team, there's a nifty little trick you can do to get your documentation up to speed. Basically, hand your new developer or your new team member your current documentation, and that becomes their ramp-up material. I guarantee you, if the documentation is wrong, they will find it. Because whatever tribal knowledge your team has developed that's not in the documentation, the new person is going to trip over it and have problems. So guess what one of the first jobs for the new person is? As they're learning, update the documentation. So by combining these three things, the documentation check, the ramp up of the new hire, and the documentation update, it generally gives you a very natural and very efficient mechanism to keep your documentation up to date and to rapidly bring up a new team member. When you do this regularly, your team member will come up to speed in a matter of weeks instead of a matter of months, depending on the complexity of the project. But typically, 4 to 5 times faster than just, handing them the code and saying, go figure this out, which, I'm pretty sure we've all been there. Okay, the hardening phase. So this is actually something that some groups include more in the testing and validation phase. I tend to like to pull it out into its own phase. Basically, this is where you deliberately go try to abuse the system and break the system. The goal here is not to use the system properly. The goal here is to outright abuse the system and make sure it responds in some reasonable or expected manner. So, stress testing. In this case, you're going to apply pressure to each aspect of the system to ensure that it continues to meet its requirements. So, this will vary depending on the project, but various things you can put pressure on: memory. What happens if we just run the system to, the limits of the computers? We're out of memory. Does it come down nicely? Does it blow up transactions? Does it just crash? Compute load, database size, network load. These are all things we typically look at. A few that's typically not looked at, unless you're doing certain classes of projects: EMI. So one of the things people have probably seen the little FCC and CE stickers on things. One of the things you have to show when you get a CE certification is that your product behaves predictably when it's struck by electrostatic discharge. And that could be electrostatic discharge. They actually have little guns that provide very precise power levels and basically spark profile. The shape of the spark is very precisely controlled. You have to go, strike your project with if it's a physical piece of hardware, strike your project with one of these EMI guns, or ESD. It's an ESD gun in this case, and make sure that it responds to that static zap in a well-behaved manner. You'll typically also go into EMI, which is electromagnetic radiation. That's related. In addition to conducted, it can also take your project down just from the little magnetic field that's given off of a spark. If you're in aerospace, There's much stronger EMI requirements. You have to look at radiation. What happens if you bombard your project with radiation? Does it do what does it behave well, or does it die? Temperature, shock, vibration. If you're in automotive, vibration and temperature are going to be a very big deal. If you work on something that tools used in the construction industry outside, one project we had a tracking system. It basically had to survive temperatures up above, I believe we were seeing 120 to 150 degrees centigrade, not because the air temperature was that hot, but because they would set it down on hot concrete, and in the sun and in the car, it would just get up to very, very high temperatures. Special tests are going to take special test facilities to do some of these. Typically with the stress testing, failures in the field are going to be difficult or impossible to diagnose. So if you don't do this up front, what you're going to get is somebody calling up and saying, my device is dead, what happened? A particular case that I thought was actually pretty amusing of this, it was the same outdoor construction device. They were using it out in the desert. And what had happened is a military aircraft flew over them very low with their radar on. And it burned out the front end of the receiver on this particular device. Had the person not realized that jet was important, all we would have gotten back is a dead box, and it's like, it doesn't work anymore. Well, the receiver's dead. How did that happen? Well, we don't know. So it's something to think about when you get into these types of projects. Fuzz testing. This is another one that's pretty common. The idea is to generally apply malformed input to the system and ensure that it behaves properly or that it rejects it. There's fuzz testing suites out there. This will actually depend on what type of project you're doing. Generally, this will get wrapped up in your security testing as well. And you can have specialized tests and setups. You generally, any input that comes from the outside, you want to fuzz. And basically make sure that if you give it just garbage input, the system can at least recover or reject that input. You can likely skip this in cases where security is not an issue and/or all your system inputs are controlled or well defined. It's if you don't know if the inputs are not going to be subjected to potentially malicious or runaway input from other systems, yeah, you can probably skip this. Penetration testing. This typically involves a third party. It's again tied up with security. They attempt to break in or break into the system. Of the various tests, this one is the one that assumes malicious intent. The others could just happen. In the case of the fighter jet that flew over, he didn't know or care that there was somebody on the ground with this particular device, and he just happened to burn it out for them. This particular type of testing, you're assuming a malicious intent to start with, and it basically further establishes the security of the system. You can skip it for a lot of systems if security is not that important, and it can be costly to do. This can actually be quite costly because it typically involves a third party, and that's external resources you're hiring to come into the project. To decide whether you want to include this or not, what you typically want to do is a cost-benefit analysis. If my system is hacked, what is the cost? And sometimes that's going to be pretty small. If my web server gets hacked, for my personal website, well, okay, I just have to go reload it. If my financial system gets hacked and they empty my bank account, that's going to be a little bit bigger. Okay, in summary, building a successful system requires multiple stages of planning and execution. Once you get a team together and start doing things, repeatedly, you'll typically develop kind of a rhythm of these, and you'll have a baseline to work from. So you're not building it all from scratch every time. You need to select the activities that are appropriate to the project at hand. And also keeping in mind that the same team may do different projects at different times that take different levels of planning. So it's very common for us to do a prototype or an exploration project up front before we get into the real project. That prototype will be very, very lightweight compared to the rigor that's applied to the actual project. Finally, you need to establish a realistic budget before starting. So a lot of teams get into a project and they have not considered a lot of the aspects. They get partway through the project and they start getting bit by these things. Oh, we didn't consider this. We didn't consider we need documentation here. Oh, we didn't know that we need to meet requirements for the Child Information Act. And then you have to go back and retrofit that into a project, which is actually a lot more expensive than doing it up front, and you're not going to have it in your budget. Either time or money when I say budget. Okay, questions. Let me stop sharing a screen here, and we'll go back to live. Let's see. There we go. Okay. Is there anybody? Let's see. Yep. So basically, questions and answers at this point. Q&A session. Does anybody have any war stories they'd like to share around this?
Your camera is still off. Would you like to turn on your camera?
Oh, I can do that. Thank you. Yep. And other people, feel free to turn on your cameras at this point too if you'd like. So. Hi. Okay, well, I've been talking for the last almost hour straight, so time for somebody else to talk. Or we could wrap up if everybody's comfy at this point. Well, I guess we'll call it done then. Okay, thanks everyone, and I'll catch you next month. If people do want to hang out, I also want to mention, after any of these meetings, if people want to hang out, feel free to stay in the chat room. It stays open until the last person leaves. So, Robin, we could go ahead and stop the recording now too.